Hey guys, we're back. Hopefully this will work a little better. So we're kind of doing the same thing, solve. When it says solve the triangle, that means find all the angles and all the sides. So I need to know angle A, angle B, and angle C, and I need to know side A, side B, and side C. Generally, you're going to be given 3 of these things at the beginning. That symbol means angle. You might know that. Angle C is 90, given that to begin with. Side B is the one across from angle B, so that's a 3. And side A is across from angle A, and that's a 3. So I got to find these 3 things. This one might be a little more straightforward because we know this actually is one of our special right triangles. So I know already that this side is 3 root 2, and both of these angles are 45. This is an isosceles right triangle, but we're going to use inverse trig just to confirm that that's the case. So you can start with any of the angles you're not given, or you can find this third side. Let's do that. Let's find the third side first. So to find side C, we know that a squared plus b squared is c squared. A squared is 9 plus b squared is also 9. That's 18, which is c squared. So c is therefore the square root of 18, which we know better as 3 root 2. And so c is 3 root 2. And that kind of agrees with what I expected. The 45, 45, 90 should be side x, and the third side is x root 2, and that's what I got. And I would expect both these angles to be 45, but we can just check. Let's see. The inverse trig functions. Let's do the inverse sine. Let's do the, sorry. Let me write the ratio for A. If I'm thinking about angle A, I'm given the opposite side and the adjacent side, not the hypotenuse. So I can say the ratio which relates opposite to adjacent is tangent. So the tangent of A is 3 over 3, which is equal to 1, but doesn't really matter. Now I can do the inverse tangent of 3 over 3. And that should be equal to angle A. And if I punch that in my calculator, I get A is 45 degrees. That's 45. And then you don't actually have to do another inverse trig. You can just subtract these two from 180 and you'll get 45 again. But you could imagine I would do the same thing for B. I'm given the opposite and the adjacent side. So I'd say the inverse tangent, sorry, the tangent of B is 3 over 3, which is the same. So I'm going to get the same number when I do that. So this is now, this triangle is solved. Check, we're done. Let's see a couple more examples here. So this one is another solving. These next two are both solving, but this time I don't know. These aren't the same kind of ratios. Like this is not a special right triangle, so I have to just figure out what the sides are. Sorry, sides and angles. Angle X, angle Y, and angle Z. I need side X, side Y, and side Z. Angle X I'm not given, angle Y I'm given as 90 degrees, and angle Z I'm also not given. Side X would be 42, but it's across from angle X. Side Y is across from angle Y, so that would be 50, and side Z I'm not given. So I can find side Z first if I want. I know that Z squared plus 42 squared should equal 50 squared. And then you can like subtract 42 squared from both sides. And if you punch it in the old calculator, 50 squared minus 42 squared is 736. So Z is, and you can maybe simplify that radical, but it says to round to the nearest hundredth. So I do that, I get 27.13. So side Z is 27.13. And now I got to use inverse trig to find either angle X or angle Z. It doesn't matter which one I start with. Whichever one I get, I'm just going to subtract 90 and that one from 180 to find the third one. So let's do X. So I look at angle X, I'm given the opposite side and the hypotenuse. And the trig function which relates the opposite side to the hypotenuse is the sine. So I could say the sine of X is 42 over 50. Which means the inverse sine of 42 over 50 is equal to X. And the inverse sine of 42 over 50 is 57.14. And that goes right here, 57.14 degrees. Then I do 180 minus 90 minus that last answer I got, and I get 32.86 for Z. Again, you could have solved for Z first and then subtracted this one and this one to get that one. You get the same answers if you do it that way. So this is, again, how we use inverse trig to solve triangles. And now this one I'm given, well, this time I'm given different things. I actually may not need to use inverse trig for this one. Angle X, angle Y, angle Z, side X, side Y, side Z. Sine says around here is 10th. I just changing that up. This is 37. This I'm not given, but I'm given Z as 90. So I have all the angles now if I want them. If I do 180 minus 90 minus 37, I get 53, which is my third angle here. I'm given side Y, which is 12. And now I can find any of the other sides I want. Let's see. Why don't we say, let's say I'm going to find this side next, side X. So I can say the sine, nope, not the sine. This is the opposite side from X, and I'm given the adjacent side from X. And the ratio which relates the opposite side to the adjacent side is the tangent. So I would say the tangent of 37 was equal to side X over 12. The tangent of this angle is the opposite side over the adjacent side, side X over 12. So that means X is 12 times the tangent of 37. That's real messy. I'm going to rewrite that. 37, and then that equals, and again, this is, I don't know the tangent of 37 off the top of my head, so I got to plug it into my calculator, and I get 9.0. I round to the nearest 10th. Side X is 9.0. And if you're going to try and find this other side, now that we know two sides, we could in theory use the Pythagorean theorem to find Z, but I would just as soon use the numbers I'm given, because this is not actually 9.0, it's 9.042648601, and then there's more numbers after that too that my calculator doesn't tell me. So this is not an exact answer, but because I'm given 37, I can assume this is exactly 37. No decimal points, or just zeros after the decimal point. And I can assume this side is exactly 12 for the same reason. So the smart thing, or the kind of the more rigorous thing to do, is to use the numbers you know are exact. So if I want to find this side here, I start with my 37, and I say the 12 is adjacent to it, and this side is the hypotenuse. And the trig function, which relates the adjacent side to the hypotenuse, is the cosine. So that means the cosine of 37 must be equal to 12 over side Z. Now a little algebra will get you that Z is 12 divided by the cosine of 37, which means that Z is equal to, and again, this is a calculator thing, punch in your calculator, and you get 15.0. 2, 5, 6, 2, 7, 9, so on and so forth. So Z is about 15.0. And that's how this triangle is now solved. And that's how we use inverse trig here to solve this triangle. And this one, you notice we didn't need to use inverse trig, we just used regular trig. But it's like kind of important that you know the distinction between those two. You could have used inverse trig for this one, but it wasn't necessary to do so. You could use inverse trig to find one of these angles or something, but just you don't have to, so don't bother. The only reason I put this one on here that doesn't use inverse trig is to demonstrate that you don't always have to use it, and it's good to know when you should use it and when you shouldn't. So I hope that was helpful, and we'll do some practice with this in class. Bye.